All right, excellent. Okay, first thing I want to talk about is I've been having, this class is pretty good about it. I will say that to start with. This class has been pretty good about answering when I call on you guys. But man, am I having a lot of problems getting people involved in the other classes. I think I'm going to have to start requiring you guys to have your cameras on because too many people are taking advantage of that to just work on other stuff or, just leave. They just join just for attendance, and that defeats the whole point of learning. So I know you guys probably hate it. I'm not going to make you do it today because maybe somebody's pajamas or whatever that they don't want to be seen. But starting Monday, I'll have to have everybody have their cameras on. I don't like it, but I kind of gave everybody a chance to at least try to work with it. And I've been having a lot of issues with participation. So it's pretty key in learning, having people participate and take part in things. And I get it. This year's kind of tough. But we'll do the best we can. So starting Monday, we'll just make sure everybody has to have their cameras on, okay? And if for some reason that's a problem, you can certainly just message me or get a hold of me and we can talk about it. Do you guys have any kind of questions from yesterday's that maybe you want me to help you go over first? We'll take a couple minutes for that if you have some. Otherwise, today's is a lot like yesterday's. So who knows, maybe your question will be answered just by going through today's problems. Okay. See, this is what I meant by participation. Like, if your camera's on, you can just do like head nods or shakes, and then I can at least have a quick answer that people are, with it. So that's kind of part of the reason. All right. Let's start 7-3. All right, excuse me. Let's finish 7-3. We started 7-3 yesterday. I noticed I incorrectly labeled it 7-2 on the title, and so maybe that kind of threw some people off. But I wrote 7-3 in the notes. So 7-3, it's basically just everything's on powers. Like, if you like titling stuff, I'll give you the same title. More power stuff. The actual title's super long. I don't feel like we need that. So I'm gonna start by going over one of the other properties. This was yesterday. Yesterday was when we have same base being multiplied. You can add their powers. So this was yesterday. Uh, 10. Okay? Well, today, I wanted to put that there because today's looks similar to it, but is totally different. Today we're going to be doing a power to a power. And yesterday, a handful of people have said that they had never seen these rules before. So I'm going to treat this as if you've never seen these before as well. And I'm going to guess, because you guys all came from different schools, different teachers, some of you might have already done this, right? So I'm just going to pretend that you've never seen this. So this is called a power to a power. Christian, what does this third power mean? Like, what does that do? You there, Christian? Oh, that'll do it. Do you remember what the third power means? Like Cubed. This isn't from yesterday. Nope, that's not from yesterday. That's okay. Cullen, do you remember what cubed means? I mean, that's kind of key to this whole thing, is knowing what these mean, right? Oh, perfect. That's a great way to say it. Yes. Yeah, the way you said it first meant different, but the way you said it that last time is perfect. So cubed means times itself 3 times. Well, if I write this out the long way, this is what it means. It means 7 to the 4th 3 times. And because I've got all these bases that are the same, I can add their powers, would give me 7 to the 12th. Now, this is not something I'm going to expect you to ever write out. Okay? Yep. That's exactly what I was. Nope, that's exactly what I was just going to write out. So you're 100% right. So instead of doing this out the long way, I was just basically writing this to show you where it comes from. If you have a power to a power, you multiply them. Because then that way, if one of these numbers is stupidly big, you're not going to take the time to write it out, right? So if you want me to write a little note on the side, if you have a power to a power, multiply the powers. So I know some of you guys like little notes like this off on the side because it kind of helps you straighten things. Some of you don't. You guys take notes however works best for you. Good God, I don't know if you can hear my cat, but she's not happy that I'm not giving her food right now, apparently. She doesn't like it when I'm teaching from home. She's not the center of attention. Cats are like that. Okay, questions on what's like up here. Because this is kind of going to be the focus of our next little bit. Okay, so I'm going to put a bunch of, oh, go ahead if somebody had one. I think I heard somebody. I'm going to put a bunch of examples up that we'll kind of do together, and they'll progressively get harder, right? So I'm going to put 3 to the 6th squared. Then we're going to have 2 to the 8th to the 0. And then we're going to have x squared to the negative 4th times x to the 5th. And then we are going to have x squared y to the 4th cubed. So we'll get progressively harder each time. Maybe I'll try to color code them so that helps a little bit. Okay, the first one I wrote is basically exactly like the example I kind of taught it to you with. So 3 to the 6th power squared. We have a power to a power, so we're going to multiply them. So it would be 3 to the 12th. You know, there's nothing more to it than that. By far, the hardest part is going to be for you guys to remember, you know, like which rule is which. If you have a hard time remembering these things, one thing that I know a lot of students have done in the past is make themselves a little note card of formulas. And you can write little examples on a note card to help you out. So if you're a person that things feel confusing, that's a good way to go around it. All right, let's... Geo, do you think you could help me with this one in, I don't even know what color that is, pinkish? I'm not good with colors. I'll leave that to Miss Frisco. Do you want me to help you through this? Or do you think you got it? You bet. Okay. So when I'm looking at this, I say 2 to the 8th to the 0. So if I have a power to a power, I'm going to multiply them together. So it's going to become 2 to the 8 times 0. And then what's 8 times 0? Perfect. Do you remember yesterday? I think it was yesterday. It feels so long ago. This is like the longest week I've had forever. I'm like losing my voice from talking so much. Do you remember what anything to the 0 power is? Perfect. Nice. Very nice. So, if you guys recognize it from the very beginning, this whole parentheses was to the 0 power. If you guys recognize that, you could have actually just written the answer of 1 from the beginning too. Either one of these routes works. Okay, nice job, Gio. Thank you. Jack, are you there? Okay, nice. What do I do? Thoughts? Good. Nope, that's perfect. Perfect. You have a power to a power, so we multiply them. This x to the 5th had nothing to do with that parentheses. Okay? Now this is from yesterday, because it's same base, but powers. So remember what I do with them if I'm multiplying? Oh, go ahead. Don't remember it? Okay, I'll scroll up. So from yesterday was, yeah. Oh, is that what you said from the start? Sorry. No, sorry. It was coming through kind of weird. It sounded to me like you said you didn't know. No, you're correct. You add them together if they're multiplied like that. Okay? And then do you remember what we do if we have a negative power as a final answer? Nice. And you do that by putting it on the bottom. Nice. I'll leave this open for anybody. Does anybody think they know what to do with the one in yellow? I don't know if I want to call this a challenge problem. Okay, what do we do? Perfect. Nice job. The cubed goes on both of them, like separately. So you're going to have x squared cubed times y 4th cubed. So if you have multiple things in the parentheses and there's like a power on it, that power goes on everything on the inside. And then I can't combine these two at the end because they're different letters. Now, how's what's up here? Does somebody want me to answer anything like a question from any one of the 4 examples, different colors? Because I certainly can. Because if you're confused on something in particular, it definitely is easier to ask a question on the easier problems before they get more complicated. Okay. Yep. So were you okay with this right here? Okay. Okay. So then basically I just added -8 and 5. So -8 and 5 turn into -3. My guess is in your head you kind of did it backwards and did 8 minus 5 or something like that. Okay, that's the end of 7.3. So I know yesterday 7.3 felt hard when we first did it because it was different. 7.4 is like putting everything... Nah, I won't even say that. I'll give it the exact same title. There is a million different titles and descriptions for rules, but in my mind, sometimes that makes it way harder to remember. Like the division property of powers. You know, that's like the title, right? Sometimes that makes it worse. Okay, so I'll start off by showing you an example of how things work, and then I'll give you the rule. So this one's all about division. Well, if I want to write this out the long way, which I don't, I could write these separate. Like, I'm not going to have you guys do this. I'm just showing you why this works. So if I have 5 3's multiplied on top and 2 3's divided on or multiplied on bottom, I can actually cancel things. And I'd be left with 3 to the third. So if you are dividing powers, you subtract them. Top minus bottom. It's not going to be the big number minus the little, because sometimes the number on bottom is bigger. It's just top minus bottom. You know what? I'll put that on there. Top minus bottom. So kind of my little note off on the side. When dividing like bases. So they're both 3's. Those are like bases. Oh, I'm sorry. I didn't see somebody wrote something. Oh, yeah, that's all right. When dividing like bases, subtract powers, top minus bottom, and write the answer on top, which doesn't make sense yet, but it will. Oh my goodness. You know what I need? I need one of those. Maybe your parents have some of them. A long time ago, the Minnesota Vikings, everybody used to buy this foam brick. And the whole purpose of this foam brick was so that when the Vikings screwed something up, you could throw the brick at the television and it wouldn't hurt it. I feel like I need one of those right now to throw at the cat. So I'll do the same thing as I did last time. If that seemed to work out okay, is I'll kind of write a bunch of examples out, and then we'll just kind of go through them progressively, getting harder. Now, I'm kind of purposely making sure that these are definitely harder along the way, because I don't want you to get hard problems in the homework and then feel like they're totally different. So try not to, don't get scared off by them. We'll go through them together. Now, I'm hoping it doesn't feel like we're going way too fast for you guys. Part of the reason we're going at this pace is because we want to make sure we finish the chapter before we leave for break. So the way it's currently set up, we'll have an extra day in there to kind of either review or possibly just have you take the test a day early so that the day before break we don't have anything. We'll kind of figure that out. Okay, we definitely need to call on Taylor. Taylor, do you think you could help me out with the green one? Okay, perfect. How come you subtracted them? Just as a quick question, but you are 100% right. That's a very fair answer. It's because they're being divided. So that is exactly why you subtracted. Yeah, no, you were correct. The reason I'm bringing that up is because once we start putting a whole bunch of these rules together, you like have to know how to look at a big problem and do it little by little. Maggie, do you want to help me with the pink one? Maybe. Okay, there you are. Okay. Yep. I'll write 5 minus -3, but you are absolutely correct. Yep. Yep. Perfect. So here's where some students get confused. It's because you have so many options. So the way that Maggie told me to do this, perfect, right? It works. One other option you could have done is you could have taken this 7 to the -3 and moved it up to the top as 7 +3, and then you could have added their powers and still got 8. Like, you have options on how to do some of these problems, and I know for some of you guys that is the hard part. Like, you would like everything to be done one way and be able to do that for all of them, but it's not always going to turn out that way. But as long as whatever you're doing is correct, the answer is going to be correct. Jeremy, I need a pro for this one. Are you going to be that pro? Okay. What do you do when there's multiple things? Perfect. Nope, that's perfect. Okay, how about the 2's? Because that one doesn't have a number written there. You guys had a couple questions like this yesterday when there was no number. Do you remember what to do with it when there's no number? You mean when I put them together? Yeah, yep. So if there's no number written there, it's like a 1. And that should have been part of your homework yesterday. Yep. So 3 minus 1. And then how about the 3's? Yep. Yeah, okay, good. Very good, Jeremy. So this is, the 3's is where I was specifically trying to tell you it's just top minus bottom. No matter what your answer comes out to be, top minus bottom. So this isn't going to be our final answer because we have a negative power in there. So the negative power is going to be the only thing that moves. The 2 squared and the 5 squared, I don't do anything with them. 3 to the -2 is going to move to the bottom. So a big part of this process is just us learning about different rules that work and being able to kind of do a bunch of them at a time, which kind of teaches you how to do logical thinking with complex thoughts. That's kind of the purpose of algebra. Hattie, what do you think about the red one? Not great thoughts? Do you want me to guide you a little bit? Okay, I can do that. So when I'm looking at this one in the red, I kind of see a parentheses. And so it's sort of like order of operations where I want to take care of parentheses things first. So the A and the B are together, and it has a fourth power in them. So the fourth power is going to go on both of them first. So the bottom, oh, these were both like a 1. I guess I didn't say that. Maybe you guys knew that. So it'd be like 1 times 4, 1 times 4. So that's what it would turn into. How about from there? Think you can go from there? Okay. Nice. Very nice. Perfect. Perfect. So for anybody else, absolutely ask away if you've got questions about, because, you know, like as these problems start having more stuff in them, that's where they can get confusing. So even if you just want to type your question in that anonymous Padlet, or if you want to put your question in chat, or if you want to just say it out loud, feel free. Okay. Then let's do the last one, which, to be honest, actually is a little bit easier than the red one. Does anybody feel like they could do the yellow one? Does anybody want to volunteer? Okay. Perfect. So 5 times 2. Yep. Good. Yep. 4 minus 1. Yep. Very good. Very good. And then our final answer, we have a negative power. So I need to move that one. So the N3, yep. Okay, go ahead. And yeah, positive 5. Nice. Very good explanation. Very good explanation. All right. Oh, I know. I'll make a poll. If I could spell. Okay, it would be kind of helpful for me if you guys could answer the poll. So if you click on the little icon with the triangle, square, circle, or whatever it is, it's an anonymous poll, so it doesn't say which one you've answered. But it would kind of help me to know where you guys are at on all these power things. Like, kind of help me know how fast to go through things. And maybe today is helping you out a little bit, you know, from like yesterday might have felt difficult at first. Okay. All right. So if you are having a lot of trouble with stuff, don't forget, I'm always on every day from 1:10 to 2:15. I leave my Google Meet open to answer questions, and I usually just do work during that time. So, okay, we only have one thing left. Only one thing left. And I wanted to make sure to see how you were doing before we did it. It's still 7-4, so you don't have to retitle anything. The difference is if you have a fraction. Now, to me, it's no different, but I know for some people it feels very different. To me, this is the same thing as when you have a couple things in the parentheses and you put the power on all of them. This is actually the same. If you have a fraction, you can put the power on top and bottom. So the power basically goes on everything within the parentheses. And then I have a different example with a fraction that might seem, it actually ends up being helpful quite a few times. So, if I have 5/6 to the -2 power, a negative power normally means we do 1 over. But on a fraction, that makes it really quite a bit more difficult. So if you have a fraction with a negative power, what you can do is flip the fraction upside down. And that gives you the same correct answer. So fractions with negative powers can be flipped upside down. A reciprocal is the correct word, but whatever. And then it turns into a positive power. And a lot of times that's going to help us quite a bit. So I will put some different examples down. I'm not even going to say they go from harder, they get harder. They're all different. And this is going to be the end for today's info. What do you think, Caleb? Do you think you could help me with the green one? Yep, sorry. That's true. I'll give you guys a minute here before we... Whenever you are ready, Caleb, you can certainly tell me what to do on green, or if you want some help with it, I can help you out. I think you mean it correct. Okay, so yeah, just tell me what to write. How's that? Good? Oh, whoa. Wait. My OCD is going to kill me if I use a yellow pen under a green problem. So 2, 3, X. Oh, good. Nice catch. Perfect. So all of these have a 1 on them because you don't write a first power. So you're going to multiply every power times 3. That is it. Nice job. Nice. Yeah, that's it. These are shorter than the ones we did before, just because it's just a different rule. Carly, do you think you could help me with the pinkish colored one? Okay, what'd you get? Oh, you know what? I think you don't see the negative symbol. Yeah. I guess I didn't even think about that. That's right. What you were saying would have worked as well. That's when you said 3 on both. I could tell you couldn't see it. What do we do with a negative power on a fraction? Right here. So right here is kind of a perfect example. If we have a negative power on a fraction, what we can do is flip the fraction, and then it's a positive power. So what would this turn into? Flip the fraction. What do we get if we flip the fraction? Perfect. Perfect. The power turns positive. And then now we do exactly what you had said in the beginning, where you put the third power on both. Because that's what you originally tried to tell me about. Very good. Very good. So flipping the fraction upside down helps if you have a negative power. Okay. Using that knowledge, we'll do the last one, which has got all the stuff in it. Which is a great question for Honey. Honey, are you ready to show your star power? Your mathematical brain. Oh, Honey, I thought it was going to be perfect. I set up for you. How about Grace? Grace, are you there? Okay. Oh, and you got a new Snapchat. Okay. No, that's okay. Do you want me to guide you through a little bit? Okay, that's all right. Okay, so what I'm going to do is, because there's 2 parentheses, I'm actually going to kind of treat it as like 2 separate problems. So I'm going to do them separate. So what do I do if I have a fraction to a negative power? Okay. And then what does the power become? Okay, perfect. Now, technically I don't have to, because to the first power is itself. Like, it doesn't change it. But you are absolutely correct. Okay, how about the second parentheses? What do we do with that? Okay, I could do that. And then this becomes a 2. Okay, so what do I do with this 2? So if I have a squared on the outside of the parentheses, it technically means I'm going to square everything on the inside. So it's going to go 3 squared, y squared, 2 squared, x squared. Oh, okay, yep, no, what you said would work. That would work too. So that's where it's kind of a gray area that I don't like. I would be okay if you left it as 3 squared. I would also be okay if you wrote it as 9. Oh God, I even wrote it as 4 on the bottom. Yeah, I'm not going to be too picky about this for correct answers. I'll take either one. So you writing a 9 and a 4 would be correct. Okay, perfect. And then kind of our last step is just going to be to put these together. So I could write it like this. Yeah, no, thank you, Grace. Sorry, I'll just finish this one off. Thank you. Good job. So you can write it like this, or you can do 4 times 9 and 3 times 4. And now that I write that, 36 divided by 12 is 3. All 3 of these answers are right. It basically just depends on how much you want to simplify it. And I'm not going to be mad if you leave everything as powers, because that's kind of what we're focusing on for this section and chapter. Oh, here, I thought we were done at 12:15. We don't get done until 12:30, right? You guys have a little bit of time to work. Okay, good. I was thinking it went right to the end of the hour. So I guess I'm done with notes for today. I mean, this is a lot of information. I know. It was probably a lot of writing for you to do. So you guys are welcome to take the last 15, 20 minutes and work on your homework. And you very well might even be able to be done depending on how quick you are at this. Otherwise, I'll stay on here for a little bit to answer some questions if you guys want to ask questions. Otherwise, have a great weekend. Make good choices this weekend. Don't make bad choices. And then I can see you guys on Monday. You bet. You bet. What was that, Gio? See ya.